Hey guys, if you missed live class today, and I believe this is going to be for Tuesday after the long break, if you didn't come back from your 4-day weekend on time, then let me tell you what you missed. First of all, a little review from last class on Thursday where we learned about convergent, divergent, and transform boundaries. You can see those here. Will you label them? These three GIFs are the three different boundaries. Remind yourself which is which. Since you missed, you don't have a pair deck, you can just answer this right on the screen though. I think GIF A, B, or C shows a blank boundary. Because remind yourself of those three, please and thank you. Okay, so remember also that plate boundaries are where two edges of tectonic plates where they meet. And they're responsible, we'll see today, for a lot of things like volcanoes, earthquakes, mountains. A lot of these things form at plate boundaries. And just reminding ourselves that after this long weekend. Okay, so let's talk about mountains and volcanoes today. First of all, look at this map. You can see that this light color, these kind of lines, show the plate boundaries. You can see volcanoes or these little yellow volcano. Look at all these over here. You can see earthquakes are these little dots. When there's an earthquake, there's a little dot at the center. Look at all these earthquakes and these volcanoes. Can you come up with what you observe? And can you infer something based on this? Again, on Pear Deck, you'd have you writing it in. But I'm hoping that you're seeing that earthquakes are happening at the plate boundaries. Volcanoes are forming at the plate boundaries. And that's 100% what I talked about a second ago. So we're going to be able to explain why that is today. So when we talk about volcanoes, I want you to make this prediction. Do you think volcanoes will form at any boundary or only some types? And so what I asked is maybe like, is it all three? Is it only in divergent boundaries when they move away from each other? Is it only in convergent boundaries where they come towards each other? Or is it in B and C, etc.? I want you to make this prediction and you'll see the answer when you do a little research in a second. After our scientists of the day and our learning target, a little bit of vocabulary. You're gonna watch a video about just generically about what a volcano is. We're gonna look at different ways volcanoes form, and then there's some practice. I think 4 slides of practice later. No quiz. This is Dr. Gladys West. You might be thinking, man, she has had a long, full life already. She is amazing. She's a mathematician. She has a PhD in math from Virginia State College, or sorry, from Virginia Tech. She got her PhD. I remember this. She got her PhD way late, which is amazing. She just thought education was so important that she got her PhD in 2018 when she was 88. Whew! Her early work, and this is her working, her early work was all about using math to create a model of what the shape of the Earth actually is. So she used all these. She helped create. Actually, I don't know how to say this word correctly. Geodesy models from satellites, and those models were incorporated into GPS. So if you ever have a phone and you're using GPS to kind of get somewhere, that works because satellites move around the Earth and can tell you where you are compared to other things, but they have to know what the shape of the Earth is. And one way they do that is using the math and the models that she came up with, which is awesome. I did a little research into like what does that mean. Basically just means like the shape of the Earth, using satellites to learn the shape. Geodesy just means the shape of the Earth, like the actual shape of what the Earth looks like. Looks like this picture's already there. But here's a zoom in of this picture. I think this is really cool. This is a long time ago when she's working, and she would build models like this because the Earth is not a sphere. The Earth is many different shapes. There are places that are further apart off the Earth, places that are closer to this. Anyway, there's just the Earth is much more complicated than we tend to think of as just like a flat ball, like you might see on a globe. And so she used satellite imagery and satellite data with mathematical modeling to get an actual accurate shape of the Earth. That's just such a big deal. She was inducted into the Hall of Fame of the Air Force for her contributions to this stuff, which is fantastic. Today, we're going to be talking about mountains and volcanoes and how they form. I want everybody leaving class today to be like, that mountain over there, I know how that thing came about. Those volcanoes, let me tell you how those are made. That's our goal today because we're trying to be able to explain how geoscience processes, and I'll talk about that word in a second, how they change our surface. Why do we have mountains and volcanoes is the topic for today. So when I talk about geoscience process, geo means, so this is like an earth science process. This is a natural process, a natural thing that happens that changes our geology, changes the rocky surface of the earth. So anything that changes the surface of the earth, you can look at some of these GIFs down here for an example. So we are going to be looking at different categories of processes over the next few lessons. So there are processes that take millions of years or billions even of years, such as anything that has to do with tectonic plates moving. That today, like we're talking about with mountains and volcanoes. Some things takes maybe hundreds, maybe thousands, maybe millions of years. That would be things like deposition, weathering, and erosion. We'll talk about that on Thursday. And there are some things that can happen really fast. Earthquakes, volcanic eruptions, a meteor impact, landslides like you see in this GIF below, but you can't because I'm in the way. These things can happen really quickly. So you can organize the different kinds of processes by the time that they take to happen. Today, we are looking at these things that take millions or billions of years to happen. Okay. For this, I want you to watch this video. Actually, can I watch it? Well, yeah, okay. So just real quick, you can see, ooh, dramatic music. You can see India here crashing into Asia and forming the Himalayan mountains, which is where Mount Everest is. There's a couple more GIFs that kind of show you that the way mountain ranges form is from two tectonic plates bumping into each other. Remind yourself, is that convergent, divergent, or transform? I'm not going to tell you. Go back and look that up. But that's the big idea of how mountains form. Whoa. So, actually, I told you right here on this slide, so it's cool. Mountains are large natural rises in elevation. You've all seen a mountain. I just want to make sure we all understand. A mountain range is a line of mountains, and it could be thousands of miles long. Mountain ranges form at convergent plate boundaries when the plate bends and buckles under each other, especially when two continental plates form. No one of them doesn't dive under the other one like sometimes happened, and then they bend and crumple and they form mountains. On Pear Deck, I asked your class during live class, how do you think a volcano is different from a mountain? So take a second and decide in your mind, how is a volcano different from a mountain? How do you know if this is a volcano or just a mountain? So volcanoes have an opening which allow lava to escape, also ash and gas sometimes. That is what a volcano is. It doesn't always actually a mountain. You can have a volcano that's low. You can have a volcano under the ocean. Yes, you can. I want to make sure we understand the difference between magma and lava. No one's going to fault you for mixing these up because they're almost the same thing. They are both liquid rock. That's what all this is under here. Rock that you heat up so hot, it melts. Super hot. And here is some lava down here. So the only difference is where it is. When this melted rock is under the earth, we call it magma. As soon as it erupts out of the earth, out of a volcano, we call it lava. That's the only difference. So you'll hear both of those. I just want you to maybe, okay, magma, lava, both melted rock, but where is it if you want to be accurate in your words? I want you to watch this video. Go ahead and pause my video. Watch this video. You're going to answer these questions: what a volcano is and how is one formed. And then on the next breakout room, we're going to dive further into that. So remember that subduction zones are where an example of a convergent boundary, two plates bumping into each other. But usually, if one plate is an ocean plate, oceanic crust hitting a a continental crust that is less dense, it's taller, then the oceanic plate dives down into it and crust is destroyed. And this makes a big difference and often will result in volcanoes. You're going to use this link. They're going to see a lot of different information about volcanoes, so click around. But there's one place that talks about subduction zones, which are examples of convergent boundaries. Spreading centers is what they call this. We're calling it a divergent boundary. You can see there's just different words for the same thing. So click on that. And then there's something called a hotspot, which is an awesome name. I want you to write a sentence or two about that type of place where a volcano forms. Like, why in that place does magma reach the surface? Explain. It could be 1 or 2 or 3 sentences maybe. Give me a real world example. Where does that happen on Earth? I think you'll find one of those each, except for, I think, the divergent boundary. They don't have one. I will tell you Mount Kilimanjaro. Booyah. In East Africa, in Tanzania. Then there's 3 GIFs here. I want you to look at each one and just to drag them into the appropriate box. There's one for each of these types of volcanoes. Again, it's just nice to kind of see a little visual as you're putting words to it, etc. For your independent work, there are 4 slides that are little practice slides. And then there's a couple of options at the end that are kind of cool. They're virtual field trips that I thought was awesome. So I wanted to show it to you. So number 1, you're going to watch this video and you're going to answer this question. Which of the 3 places where a volcano forms, convergent plates, divergent plates, hotspots, fits this Mount Vesuvius, which is a famous volcano in Italy? Tell me about it in 2 or 3 sentences below. For this one, tell me about the islands of Hawaii. Tell me what you would expect Hawaii to look like if you came back in 50 million years, if you had a time machine. What would it look like? Tell me about it. Watch this formation of Himalaya simulation and tell me what happened with the tectonic plates to form this mountain range. This might be the easiest one because we even talked about it a little bit earlier, but that's good. I haven't asked you to use your own words, so take the second and give me 2 or 3 sentences about what happens to make these tallest mountains in the world exist. And then finally, let's zoom in on us here in here. Seattle would be like here, so we are like right here. If you see my little dot right there, that's where we live in Washington. So I want to know how our Mount Rainier. Here's Mount Rainier, and then there's a bunch of other volcanoes in the Northwest. In Washington, you have Mount Baker. It's the 3rd tallest. Mount Adams is the 2nd tallest. Glacier Peak is the 4th. Mount St. Helens, is after it blew its top, it's not nearly as tall as the others. I don't know if it's in the top 5 anymore, but it is. Those are the major volcanoes in the area. And then there's more. Mount Hood in Oregon, Jefferson Sisters all the way through Mount Shasta down in Northern California. How did these volcanoes form? Look at the map carefully. Remember, look at our Juan de Fuca plate. Read what it talks about here and tell me, explain here how it forms. There's also another little picture down here that might help you with that. Then if you want to learn more, this is a cool website. It talks more about volcanoes, different things like different kinds of volcanoes, different shapes, etc. Different stuff than I went over in class today. And then this is really cool. I didn't even know this existed. This is like a Google thing. You can take a virtual field trip through the Volcanoes National Park on the Big Island in Hawaii. Pretty cool. I spent a few more minutes than I meant to, just kind of like clicking around going, wow, this is cool. So if you have a minute, go do that as well. And I will see you guys tomorrow.